Welcome to Mechanical Tutorial. I am going to teach you different techniques in SolidWorks for mechanical engineers. I am going to train you different modules like surface modeling, sheet metal and enclosure design, product design, plastic components design, reverse engineering and many more tips and tricks in SolidWorks. Hi, today I am going to explain about diaphragm pump housing. So left side you can see housing. This is the plastic component which is going to cover on the diaphragm. See, this is the exploded view of the diaphragm pump. See, inside you can see valves, diaphragm, and the other side is motor, and left side you can see the housing. So I am going to show you how to create this component. See, this is the pump. So I am going to show you how to create this housing. I am focusing mainly on the casing body. I am not focusing on the internal components. Those are simple extruded features. So I am going to focus on the outer body. So let's start now. I have taken a new SolidWorks part file. Select the top plane, go to sketch. Here I have created this sketch. Take 3-point arc. See, here don't make the tangency. Later we can apply fillet on this edge. So we have to create one center line. So it's easy for us to select the center line while creating the revolve feature. Now I am going to constrain the sketch. Now go to revolve feature. So sketch is automatically selected and center line also. Say OK. See, the dome shape is created now. Select the front plane. So make it coincide both the sides. See here, don't convert this entity and to close the loop, because it is a doom shape, it will show an error. So to avoid such problem, take 3-point arc you can give any radius. Now go to Extruded Cut. See the direction, it is in opposite side. So simply drag it. See, this cutout is created now. Now go to now I am going to create pattern, that is circular pattern. See here, there is an imaginary axis. See here, we can uncheck these identities and go for temporary axis. We have to click this, so automatically it shows the imaginary axis or temporary axis. Select this and select the cutout feature. Here the instances are 3. Say OK. See here, it is created. Now I am going to create inlet and outlet tube. Select the right plane. Keep it in wireframe. So it should be coincide with the center axis. Here we have to select the minimum value. Now we have to modify to 1 mm. The diameter is 25. See, it is created at the center. Now go to extruded boss. Keep it in mid plane. Say OK. See here. Now we have to remove the additional material in this tube. So select the face, go to sketch, keep it normal. Now select one of the edge, convert entity. Now select the one of the point and join this. Go to Extruded Cut, keep it in shaded form and check the direction. We have to flip this. Now we have to add fillet at this location. This is 1 mm. Once again select the fillet, select the circular edge, say OK. Now this solid block is ready. Now we have to create shell feature. Select these all the three faces and the thickness is 3 mm. See, now I am going to create external features. Select this face, go to sketch, keep it normal. Go to convert entities, select inner loop one by one and select this arc. Don't select this line, it won't select the loop. So select this arc. Now take a center circle, $80 mm, go to extruded boss. Say OK. Now I am going to create this cutout. Select this face, go to sketch, keep it normal and keep it in wireframe. Here we have to go to convert entities, select the arc, automatically it selects the inner edge. So we have to check this inner loop one by one, say OK. Now we have to convert this into construction and select all the sketches, take offset entity of 3 mm, say OK. Draw a circle of any diameter and go to Extruded Cut, and take 2 mm. Now select this face, go to sketch, keep it normal, keep it in wireframe. Select this edge and convert entity. And select this circle and convert entity. Take power trim, delete this, take corner trim once again and trim these entities. Now select this line, right click and select midpoint and select the origin, make it coincide so it is exactly at the center. Sketch is defined now. Select the sketch, select up to surface, say OK. Since it is a symmetric component, we can mirror this feature. So select this feature, go to mirror entity, select the right plane, say OK. I'm going to create a rib, take a plane, select right plane, and this origin, take an angle, flip the direction, say OK. Select this plane, go to cross section, say OK. Select this plane, go to sketch, keep it normal. Now keep it in wireframe. See, the rib has been created now. At this moment I am not constraining. We can constrain and we can provide any dimension to this rib. Now I am going to create one more rib from the other side. So select this rib, go to mirror entity, and select this right plane. Say OK. Now select right plane, create a plane at the offset of 5 mm. Select this plane, go to sketch, keep it normal. Go to feature, select the rib, see here. So here I am explaining the concept, so we can constrain of any dimension. Now we have to mirror this rib. So select this rib, go to mirror entities, mirror feature, select the right plane, say OK. Now hide this plane. Now I am going to create this circular ear feature. Select this face, go to sketch, keep it normal. Draw a center line. Keep it vertical. Now draw an arc. Join these two points, that is midpoint and center axis. So it is symmetric about the axis now. Now go to feature, select up to surface. Here we have to make a tangency. Make these two horizontal. Make it 6. This is 40. Go to extrude feature. So up to surface. Select this face once again. Go to sketch, keep it normal. Take it in wireframe. Draw a circle. So move near to this edge. This is the center point. So this diameter is according to screw fastener. Go to Extruded Cut. So simply you can drag or can give any distance. See, this is not created properly. Go to edit feature. Up to surface. Now we have to apply fillets. So fillet is of 3 mm. Now select all the 4 features and go to circular pattern and select this temporary axis. Say OK. See, all the 3 features are created now. So I am going to create this arrow. Before creating arrow, we have to split the surface. Select the front plane, go to split line, say OK. So it is divided into two halves. Now I have created a sketch on the front plane. So this is the arrow I have created on the front plane and place it over here. We can take any dimension. Now select this sketch, go to feature and wrap. Select this face. It should be embossed and 1 mm height. Now similarly we have to create the other side also. Select the front plane, select the sketch, keep it normal, keep it in wireframe. Now I am going to paste this sketch once again and move this location and place it at the location required. Keep it in shaded form. You can see the direction. See, split other side also we have to select. So the split will happen the same time. So select the sketch, go to feature and select wrap. Say OK. Without splitting it doesn't take. Has been created now. Next I am going to add this text. So here select this face, go to sketch, keep it normal and type text on it. So I can use Diaphragm Pump Housing. Simply keeping diaphragm pump. See here we can change the font. See, for better visibility I always prefer Arial round. Say OK. See, this is visible and we can change the font height or font size. So I am increasing little bit by 18. Now go to insert. We have to come out of this K. Here usually we make it with extrude. Either we can do it with extrude feature or we can use wrap feature, because here we can emboss a debossing. So here I am going to show embossing. So we have to select the face. See, it is embossing. So if I take 3 mm for example for visibility, say OK. So it is always better to use wrap feature for these kinds of logos or symbols or text. So for better visibility I have taken 3 mm, usually it will be less than 1 mm. So this is how we create these kind of plastic components using simple solid features instead of using surfacing. Thank you.